This video is going to talk about mid-segments of triangles. So a mid-segment is a segment that joins two midpoints of two sides of a triangle. So take a look here. AB has a midpoint of D and AC has a midpoint of E. So if you connect those two, DE becomes a mid-segment. Now some of the special properties with that is DE is parallel to CB. All of the mid-segments will be parallel to a corresponding side on the triangle. And the other special property is that that mid-segment is equal to 1/2 of the side that it's parallel to. So if BC was 10, DE would be 5. So there's a couple special properties here. These can be used for a lot of different types of application. So let's identify three pairs of parallel segments. So let's start with DF. That's an E, so let's start with DE. DE is, I guess we're starting over. DE is parallel to the one that's across from it, BC. And then now let's actually do DF. DF is parallel to, that's horizontal, so the other one that's horizontal is AC. And the other one that's missing is EF. EF is parallel to the one across from it, AB. Points D, E, and F are midpoints, meaning DE, EF, and DF are all mid-segments. We know DE is 10, BA, that entire segment is 14, and AC, that entire one is 12. So now let's start finding everything. So if this is 10, I know that each of these are 10, making this entire side 20. If that's 14, that's 7, and each of these are 7. And if that's 12, this is 6, with each of these being 6. So AD is half of the 14, 7. EC is half of the 12. BC was double the mid-segment, so 20. And DF was half, because it was a mid-segment, or 6. Let's go ahead and look at the next example. We got three different variations here. We want to solve for x. They're all mid-segments, so this one, half of 18, that's 9. Over here, 84 is twice as big, so we're going to use 42 equals 3x. We're going to divide by 3. X is 14. Over here, I know that 5x minus 2, I could do what I did up here, and I could cut it in half. The issue is, I'd have to divide 5 by 2, and that gives me a fraction, and everybody hates fractions. So I could have done this one a different way. I could have said 84 is equal to twice as much as this, 6x. Oh, sorry, twice as much of 3x, which is 6x. And then I divide by 6, and I still get 14. So down here, instead of taking 5x minus 2 and cutting it in half, I'm going to take the 4, I'm going to multiply it by 2. And then I'm going to add 2 to both sides. 5x equals 10, giving me x is 2. Now I could have also just thought about that if this is 4, this has to be 8. That's what I'm essentially doing, and you could do that mentally as well. And our last example for mid-segments is going to be a very quick section. We want to find x, y, and z. So y and z are going to be done the same way because these two are broken apart by midpoints. A and B are midpoints. So let's go ahead and find y and z first. Since A is a midpoint, I know 6y minus 11 is equal to 4y plus 1. That's an 11. I'm going to subtract 4x from both sides. I'm going to add 11 to both sides and get these turned into x's partway through. These are supposed to be y's. Let me fix all those because that's going to be confusing later on. So we got 2y and 2y, and now y equals 6. Now for z, I'm going to do the exact same thing. I'll even change colors. 10z minus 16 equals 3z plus 5. I'm going to subtract 3z from both sides. I'm going to add 16 to both sides and get 21. Divide z is equal to 3. Now I need to solve for x differently because x plus 6 is not equal to 2x. So what I have to do is I have to take x plus 6 and I have to either equal it to twice as much of this, or I have to divide this by 2. And because it's going to be easier to double, I will do that. X plus 6 equals 4x. So 6 equals 3x. I'm just subtracting x. I get x is equal to 2.